Now that we've learned about roots with higher degree values and simplifying radicals, we need to take this concept just a step farther, and we can mix it with our understanding of our properties of exponents. Sometimes what happens in a radical, we have a root value with the radical, but we also have a power for the radicand. So we can convert this actually to an exponent property. And the types of exponents that we're dealing with are what we call rational exponents. Now what a rational exponent is the same thing as a rational number. If you remember, rational numbers can be written as fractions. And so basically what that means is that we're going to have exponents that are written in fractional form. And so the first skill that you need to develop in this particular lesson is that you need to understand how to write a rational exponent from a radical and vice versa. So we'll look at how we do that first before we jump into solving any problems or simplifying any expressions. So if you look at some of these examples that I have down here, really what we've got going on here, and I'll just use the square root of a as the first example. The square root of a really has a couple understood parts in here. It has an understood 2 there for the root, and then it also has an understood power of 1 for the a. And so what this does is it converts to the rational exponent, the exponent written in a fractional form. We have 1/2. Now, a couple things that you want to look at here. Notice where the 2 comes from. In the rational exponent, that 2 is a result of the root or the index from the radical. Okay? And so you can kind of make that connection there. And then the other part, the numerator, is the power or the exponent of the given value underneath the radical. And so you'll need to kind of make this connection on how to rewrite radicals to exponents. Now, the other thing that you're going to find is helpful at times is that not only can we write this square root of a in this manner, but the square root of a can also be written in this manner. We can have the square root in its root place, but that power of 1 could technically be outside as well. It does not have to be underneath the radical like in the original example. So you're going to have to learn when to change that, when to make that decision based off of the type of problem you're trying to simplify. Sometimes it's easier with it underneath the radical. Sometimes it's easier written as a power outside the radical, but they both mean the same thing. So the first skill that you really need to learn is how to rewrite back and forth, and that's what we've got right here in this little concept summary box. And our first example, you can see that we have in part A rewritten 9 to 3/2 in a couple different ways. The first way we converted it to a radical, and you'll notice that that power of 3 is outside instead of underneath. Or we have just broken up the fraction and dealt with the rational exponent by itself. So either way works. So you just have to try to figure out the best way for you. Now, if we take a look at sample problem number 1, it says to simplify, and so you could at this point really just take your calculator and punch this straight into your calculator. Now obviously that's a skill that you're going to need to have, and you would want to use the caret button for that. So like if we did 16 and you used a little caret symbol, and then you would just do simply 5 divided by 2, and that would give you the answer straight away. But what we would prefer you to do is to get you to work on converting and simplifying through that method, because what's going to happen in later questions and later problems is that instead of having a 16 there, you're going to have a variable like x or y there, and you're going to need to know the mechanics of moving things around, and your calculator won't help you with that. So even though you'll eventually use your calculator in these two samples, I would definitely try to work it down, whittle it down as far as you can first without a calculator. So go ahead and give sample problem 1 a try. Okay, so hopefully what you did to start, if you prefer this method, is you converted this to a radical. Now let's remember that the denominator part, goes as the root. Now you have a decision to make with the 5. Do I put the 5 underneath with the 16, or do I put the 5 on the outside? And what you probably are going to need to do is figure out first which one of these would you know? Do you know 16 to the 5th, or do you know the square root of 16? And of course, I know the square root of 16 better, so square root of 16 is 4, and then I have 4 to the 5th. And at this point, you probably don't know that, but over time working with these numbers, you'll start to learn a few of them. So right now, you could probably punch that in your calculator to get the final answer. Alright, and so that's part A. So part B, if you look back at the concept summary, you remember with exponents that are negatives, we really need to make them a positive exponent before we do anything else, so that we put it underneath 1. Now I'm going to convert this to a radical. Again, I got to make a little decision here. Cube root of 64 or 64 squared. I like the cube root of 64 better, so I'm going to put the square on the outside. And the cube root of 64 is 4, so that leaves me 4 squared, which is 1 over 16, and that's my final simplification. Okay, so you've gotten a good introduction here to how to convert between a radical and a rational exponent. That's going to be an important skill for this lesson and for the rest of this unit. So make sure you have a clear understanding about that.